Hey guys, how's it going? In this video, I'm going to go through Leetcode 76 minimum window substring. This problem was asked by Facebook for 22 times in the past 6 months, and this is a hard problem. So given two strings, S and T of length M and N, respectively, return the minimum window substring of S such that every character in T, including its duplicate, is included in the window. If there's no such substring, return the empty string. Okay. So example, we are given a string looks like this, and the target is A, B, and C, right? So the shortest substring that contains all these three characters will be B, A, N, and C. That's the last four characters. Okay. So and another example, if we have a one character of a string, and the target is the same, so immediately the entire string will be contains the single character. And in this case, and the third example, in this case, the given string is only one single character, and the target is double characters. So it's impossible to find substring that contains the two A's. So one immediately, so we can think of a brute force approach. We can have two for loops to find all the possible substrings, and that's going to take big of n square. And then for each of the substrings to check, we can check whether that substring is desirable or not. So let's take another big over n. So if we apply a brute force approach, it's gonna take a big over n cube, right? And we know that it's not very efficient. So one approach to solve this problem would be using a sliding window. So, but actually, it's already gives some hint in the problems, right? It says minimum window. So we might use the sliding window technique. Let's see how can we approach that. So it takes a few steps. So let's look at the example over here. We are given a string A, B, A, A, C, B, A, B, and the target is A, B, C. So the first step is to initialize a two pointers left and right, as just like most of the two pointers Windows problems. So we have two pointers, and then the first step is to use the right pointer to expand the window until we get a desirable window. So for example, first step, we initialize the pointer at the first position, and then now we move the right pointer, go all the way to here until we find all the desired target characters. In this case is A, B, and C, right? So this is the first window that contains all these three characters. And the first A over here, B is here, C is here. And then now what we do is to move the left pointer one at a time until and then each step when we move the left pointer, and then we can check whether the window is still desirable or not. If it is not desirable, like in this case, we move the left pointer one, actually it's still desirable, right? We have A in here, we have B in here, and we have C in here. And then now we keep moving the left pointer until it's no longer desirable, right? After the left pointer at this point, at this spot, right? And then we lost a B in the window, right? We have only A, and C. And now we move the right pointer to search for the B that we just lost it. Okay, and as you can see, this is the new window. That is a new window that's desirable. Okay, so we can compare, right? Each time we find a new window, and then we can compare all the eligible windows, right? This is the first window. How many characters? 1, 2, 3, 4, 5, right? Second window, 1, 2, 3, 4, 4 for length. And this is the third one, right? 1, 2, 3, 4. So 4 for the length. And then we keep doing that until we find all the eligible windows. And then we pick the shortest one, which is this one over here. So let's see how can we implement that in code. First, we have a dictionary I call it dict needed. So basically it's a counter. So essentially, let me show it to you what this is representing. Oops. So basically it counts all the, so for each of the needed characters, it counts the frequency, the occurrence that we need for that character, for the T, which is the target, okay? And then now we have a window count. So basically this keeps track of uh, the characters and its occurrence when we move along the window, right? My solution is not exactly the same as the official solution. That's why I haven't. I'm not gonna show you the official solution. So now I have a helper function. So essentially, this is the check to check whether the moving windows is disabled or not. So I'm gonna walk through this helper function later after we actually use it. Actually, it's very simple over here. As you can see, we just check one dictionary whether it's a subset of another dictionary. And another reason why I don't show you the official solution is that I think this is more intuitive, and it's the same time complexity. So let's carry on. So we have a left and right pointer. Also, we have the minimum length, the length of substring that we can keep track of. And I initialize as a infinity number. And then have the current the current window that I'm looking at currently at the beginning will be the empty string. And while the right pointer is within bound. And then have the window count to keep track of the character within the window and its occurrence, right? So I look at that character. So the R index of that string, basically this is a particular character that we're looking at. We increase the count by 1 when we include that character in the window. And now we check whether the window is disabled or not. Okay, so basically we are checking the dict needed is just subset of a window count or not. So that means whether our current window count includes all the target characters. Okay, and now we can look at the function a little bit more details. So we return. So this is a true or false statement basically, and we have to check all of the keys in the A dict. In this case will be the dict needed for check all the keys. If that value in the A dict, so basically in the dict needed is less than or equal to the current window count, which is counting for that particular occurrence. Okay, if that number is less than our current window, so that means we include all the characters. Okay, so that's is a subset function, and this is why we need it. And then now we moving. So now after we get into this while loop, we are moving the left pointer. Okay, until the window is no longer desirable, as we saw in diagram before. So and before we moving the left pointer, we check the length of the window, where we updating this mean length. Right, basically if the R minus L, which is the length of the current window, is less than the minimum length, and then we update that. So this the length that we're looking at will be the minimum length. Also, we update the window as well. And also these lines increase the efficiency a little bit, because if the length is equal to the shortest length possible, which is the length of the target, we immediately break out the entire function to return the window. So after we update the window, the minimum size, and then we move the left pointer. At the same time, we decrease the window count by 1 for that particular character. Okay. Once again, this while loop is to move the left pointer until the window is no longer desirable, and then we increase the right pointer to go out to search for the key character that is moved, that's been left out by moving the left pointer. I hope this is clear. So we just keep searching the windows in these two for loops. Let's submit that. And for time complexity, it's gonna be big O of the size of M plus the size of T. So in the worst case, we will traverse the S string exactly 2 times. For example, if we have a string looks like this, A, and the target is A, which is a single character, in that case, we will traverse the string exactly 2 times, right, by this algorithm. And for space complexity, we need a window count. So in the worst case, we will have like a 26 characters all occupied. So it's gonna be big of 26. So this is my solution. I hope this is helpful. Thanks so much for watching. See you next one.